Euclidean Geometry, Part 4. Now we move on to Grade 12 Geometry. In this video, we are going to discuss the Proportionality Theorem. Very important theorem for the metric learners. Listen very carefully. Now, before we learn the Proportionality Theorem, I just want to give you a basic information about the triangles in between two parallel lines. Triangles with equal or common bases lying between parallel lines have the same area. Look at the parallel lines and you can see the height or the distance, perpendicular distance between the parallel lines are also marked in dotted lines. It is named H. Now let us discuss the triangles. Triangle ABC. Another triangle. Okay, we can call it BCD or DCB. Anyway, we can call, but fortunately what we notice, the base for the two triangles is the same. BC is the base. And what is the height? H. And we know that area of a triangle is half times base times height. In this case, the base is common and also the height is common. So half times base times height for the first triangle and half times base times height for the second triangle is also same. Therefore, we conclude area of triangle ABC will be equal to area of triangle DBC. Okay. Let us look at the second diagram. Another triangle here, EFH. Think about one more triangle with the same base. Okay, we have another triangle, EGH, and the base is the same. What is the base? EH, and the height is also same. Now the area of these two triangles will be equal. Okay, so that is what I wanted to tell you before we proceed to the beautiful theorem. So here is the most important theorem for the metric learners. A line drawn parallel to one side of a triangle cuts the other two sides so as to divide them in the same proportion. A line drawn parallel to one side, what is that? Look at this line. DE is parallel to BC. A line drawn, DE is drawn parallel to BC. Then this line DE will divide the other two sides. What are the other two sides? AB and AC in the same proportion. Okay, what is the meaning? AD over DB will be equal to AE over EC. Or you can also say AB over AD will be equal to AC over AE. You can either way write. So we are going to prove it now. That is our question. Maybe 5 plus or minus 5 marks. So given information, what is given? DE is parallel to BC. We start there. Now required to prove, what are we going to prove? AD over DB is equal to AE over EC. Very clear illustration. Okay. Now we mark or we shade. For example, for illustration, you don't need to shade it in the exam. Just to make it very clear, I am shading the triangle. Look at the triangle ADE, okay? And another triangle, we shade another triangle in between the two parallel lines. So we have two triangles now. Let us write down the areas. Okay, what is the height? Height is h for both triangles. You look at the big triangle, the height is from the vertex to the base. Okay, height 90 degree. Again, the second triangle, base is dB. Where is the height? It's not inside. It is from the opposite vertex to the base extended. You extend the base and then you have the height here. So these two triangles have the same height. Now we write this step. Area of ADE over divided by area of DBE. What is the area of ADE? Half times base, that is AD, times height. You understand? Okay. Divided by area of DBE. What is the base? Base is DB. And what is the height? Again, the same height h. So we write half times dB times h. We simplify the numerator and denominator, half and half cancelled, h and h cancelled. We are left with AD over dB. Keep it. We continue. Look at the height of this triangle. Now, when we take AE as the base, we are going to take AE as the base. Now, from the opposite vertex to the base, the height is marked K. The same way, we have another triangle. We mark another triangle in the parallel lines. Look at this one. The base is EC, but where is the height? It is not inside the triangle. It is outside. Okay, we extend this base and mark the 90 degree height, the K. So what is the area? Area of ADE or AED, same triangle, is half times AE times K. Hope you understand. Half times base times height. Divided by area of ECD. Look at this blue triangle. Okay. Half times EC, the base is EC. But what is the height? K. Now we simplify. Half and half cancelled. K and K cancelled. We get AE over EC. Simple method. Don't need to shade like this, but you draw a triangle, construct a triangles like this, okay, with your pencil. Now we keep this one in mind. Look at the numerator. Look at the numerator. ADE. Here ADE. But look at the denominator. DBE, the small triangles. ECD. Now what we understand here, they lie between the parallel lines with the same base. What is the base? DE. Therefore, the areas of these two triangles are equal. Okay. Look at the diagram again. We are writing. But area of BDE is equal to area of CED. What is the reason? Same base DE. Same height, because they lie in between the two parallel lines. Same height, same base, because they lie in between the parallel lines. So the areas of them are equal. They are the denominators, okay? Numerators, same triangle. Now the denominators are also become equal. Very clear explanation. Now, then therefore we say numerator same, denominator equal. So they we say equal to. Okay, both are equal. Therefore we conclude. Therefore the simplified answer, we have this answer. AD over DB is equal to. This is AD over DB. This is AE over EC in the previous slide. So we get the conclusion. Okay. So we prove that AD over DB is equal to AE over EC. Finished. Now whenever you use this, you apply this theorem in any of the riders, Write the reason. Line parallel one side of triangle. Okay, finished. We must also know the converse of proportionality theorem. It's not examinable, but for the answering of riders, sometimes we can use this. If a line cuts two sides of a triangle proportionally, then that line is parallel to the third side. So when you use that information in any of the questions, the reason you are going to write in the bracket, line divides sides of triangle proportionally. Okay, so that's why we say that line is parallel. Okay, again, the midpoint theorem. Midpoint theorem is a special case of the proportionality theorem. The line segment joining the midpoints of two sides of a triangle, you can see that the midpoint is D and another midpoint of AC is E. So if you join these two midpoints, okay, you can also see the notations or symbols there. These sides are equal. This equal here. So DE is obtained by joining the midpoints. Then this DE is parallel to the third side. What is the third side? BC. And at the same time it will be equal to half of the third side. If this is 2x, then this is x. So we can also use these informations in some of the questions. Okay, so that's also for this topic. That is part 4 of Euclidean geometry videos. We will practice few good questions in the next video on proportionality theorem.